Factoring. Factoring where the value in front of the first variable is not 1. Negative 3, 3, 2, 6. I've been meaning to do a video on this for a while, so I got a nice reminder. So what I do is first see if I can factor anything out. If there's a negative, I'm definitely going to pull out the negative, because then I'm better at factoring from there. So it's a squared minus a minus 20. For those who don't understand what I just did, do the opposite. Distribute the negative. Negative a squared, negative, negative, positive a, negative, negative 20, positive 20. And then we look for a value. It's negative, negative, so I'm going to go with plus minus. That multiplies to negative 20, positive, negative, and adds to negative 1. I haven't done this fairly often. I know that's the case. So negative 5 times 4 is negative 20. Negative 5 plus 4 is negative 1. Doing it again, being aware that some of these might be prime, so don't always assume they're going to work. Now, since this is minus plus, it goes minus minus. What multiplies to 27 adds to negative 12, negative 9, negative 3. Yeah. Now, I'm going to come back to this one. Here's how I was taught by a student I was tutoring how to factor these. This student does this very bizarre thing, and you have to be really careful. Among other things, you have to make sure it's completely factored of all greatest common factors. Do I have one on the board? I don't. So he multiplies 6 and negative 5 and gets negative 30. And then he rewrites the problem. Don't worry, I'll bring the 6 back later. He knows how to factor this. What multiplies to negative 30, c minus, c plus, and adds. So we just did one very similar to this. And then he brings the 6 back here, divide by 6, and here, divide by 6. Now, this part's a little strange to people, and they say, well, why do you do that? And the answer is because, and that's the only answer I have, because it works. 6 over 6 is 1. Cool, c minus 1. 5 over 6 doesn't divide evenly, so I throw the 6 up here. 6c plus 5. Now, when I said because, what I meant was because it works. Negative 6 plus 5 is negative 1. Nice. 6c times c is 6c squared. And then negative 1 times 5 is negative 5. It works. I thought it was a pretty inspired little method. And I've seen quite a few different teaching methods for this, and none of them ever resonated with me. This one definitely did. So let's try it again here. D squared plus 10d plus 27. What multiplies to 27 and adds to 10? 27 times 1, 9 times 3, that's it. It's 3 times 9, but since it's plus plus, who cares? 9 and 3 is 12, that's 28. Nothing does. It's prime. 2 times negative 63 minus 126. All right. This one's a little tricky. I might even bust out a calculator and say, well, it's 2 times 63. There's a 9 and a 7 in here. Let's try 126 divided by 9. So that would be 9 and 14. Those are 5 apart. So it looks like 9 and 14 will work. F plus 14, F minus 9. I just showed they multiply and then they add. Hey, nice, but don't forget that 2 comes back. Here it divides evenly. Here it does not. So I'm going to put it up here. And I will get F plus 7 times 2F minus 9. 2F squared, 14F minus 9F, 5F, 7 times negative 9. So this is my factoring when the coefficient in front of the x squared is not 1. Pretty slick technique. I've been meaning to put this on for a while. So 3 times 10, x squared minus 17x plus 30. 10 and no, 15 and 2, x minus 15, x minus 2. Yeah. Over 3, put it up here. X minus 5, 3x minus 2, 3x squared minus 15 minus 2 minus 17 plus 10 works. Just told you this a second ago. I don't work well with negatives. We don't get along very well. So I'm going to pull it out. Then I'm going to use my technique, y squared minus 5y minus 6, y minus 6, y plus 1. Looks good. Divide by the number I threw away, 2. Throw it up here because it doesn't divide nice. Y minus 3, 2y plus 1. 2y squared, negative 6 plus 1. Ooh, I got to go here. Negative 6 plus 1. Yeah, negative 3 works. Negative, I'm going to do 2 steps at once. Oh, no, I'm not, because I'll make a mistake. Plus 13y plus 6. Y squared plus 13y plus 36. 12 and 3, no. 9 and 4, yes. Negative y plus 9, y plus 4. Number we threw away was 6. Doesn't fit on either of them, but it does reduce to 3 over 2 and 2 over 3. This is making me very nervous that I made a mistake. 9 times 4, 9 plus 4, 6 times 6, 36. Looks good to me. Minus 2y plus 3, 3y plus 2. Don't forget to go here. 2 times 3 is 6y squared. 9 plus 4, 13y. 3 times 2 is 6. There it is. A squared plus 9a plus 20. A plus 5. A plus 4. By the way, I can never make my a's without them getting really weird, so apologies. Throughout the 4, divide by 4, divide by 4. 5a plus 4, a plus 1. 5a squared, 4, 9, 4, mistake. Wrote this wrong. Be 4a squared. 4a plus 5. 4a plus 5. Notice the really good teacher demonstration of pretending to make a mistake and actually solving the problem. So these are all special cases. Hopefully you've seen them before. I'll do them just because I'm here. I'm making a video. Might as well be thorough. Difference of 2 squares. I always have to do the positive first for no reason whatsoever. Not the difference of 2 squares. Does not work. Prime. Pull out a 3m squared minus n squared. Remember, always take that GCF out. M plus n, m minus n. Difference of 2 squares, y squared minus plus z, y squared minus z. That's it, done. Pull out the 5. X squared minus 9a squared. X plus 3a. X minus 3a. This is difference, it's not difference because it's not subtracting sum of cubes. So I don't really remember how to do this. It's been a little while. I do remember you take the z out, then you jam them together, 5z, and then you square that. I think you get 25. I think this is the case. And then it's a SOAP problem. Same sign, so this was a plus. opposite sign, that's a negative, and this is always positive. Z to the third minus 10z squared plus 10z squared by plus 25z minus 25z by plus 125. Checks. My check was very lazy there because it's the end of my video and I'm being lazy, but hopefully this helps. Good luck and happy math.